Hello folks, welcome to this video where I will be teaching you about what API is, its different testing types, tools, and benefits to improve software quality and reliability. APIs are the buzzword of the software industry these days. They power most modern applications and allow seamless communication between different systems, services, and platforms. From booking a cab to making online payments, APIs silently work in the background to connect everything. They not only save development time but also enhance scalability, flexibility, and innovation for businesses. In short, APIs act as the backbone of the digital ecosystem we rely on every day. Before we begin to discuss API testing, let's first understand what an API is. API stands for Application Programming Interface. It acts as a bridge that allows two software components to communicate with each other by following a common set of rules and guidelines. In simple terms, they act like messengers that carry request and deliver responses between applications. Whether it's checking the weather on your phone or logging into a website with your Google account, APIs enable these interactions. They simplify complex integrations, improve efficiency, and make it easier to design fresh and impactful digital experiences. The following are the day-to-day examples of APIs. Online shopping. When you pay with PayPal or another gateway, APIs handle the secure transactions between the store and the payment provider. Booking flights and hotels. APIs connect airlines, travel agencies, and payment systems to provide you with real-time availability and prices. Social media sharing. Clicking share on Twitter or LinkedIn uses APIs to post directly from one app to another. Let's talk about the types of APIs based on their architecture or protocols. The popular being the REST API. REST stands for Representational State Transfer. It is a software architecture that lays out a set of rules and guidelines for designing and building APIs. An application that follows the REST architectural principles is often referred to as RESTful. When a client makes a request through a RESTful API, it sends back a representation of the resource state to the requester or endpoint. This representation can be delivered in various formats over HTTP, such as JSON, that is JavaScript Object Notation, HTML, XML, plain text, or even language-specific formats like Python or PHP. Among these, JSON is the most widely used because it's lightweight, easy for human to read, simple for machines to parse, and works independently of any programming languages. In REST APIs, headers and parameters play a key role for carrying details such as metadata, authorization, URIs, caching, and cookies. Both request and response headers provide essential information about the connection, including status codes and how the request is handled. The next is SOAP, which stands for Simple Object Access Protocol. It is a protocol that enables different systems to share information in a highly structured manner. Each message is written in XML and placed inside a standard envelope that contains both the request and the necessary details about it. The rules for this communication are defined in WSDL, that is Web Services Description Language, which works like a contract between the sender and the receiver. While SOAP is commonly used over HTTP, it can also run on other protocols such as SMTP or TCP. This flexibility enables it to adapt to various types of infrastructure and communication needs. SOAP relies on XML as the format for sending and receiving messages between an API client and server. It also defines 4 key aspects or dimensions that shape how API protocol works. The first one is envelope, that sets the overall structure of the SOAP message. The next comes encoding, which explains how different types of data should be represented. Then comes the request that defines the format and details of what the client sends. And finally, the responses, which define the format and details of what the server sends back. SOAP APIs are often used in industries such as financial, healthcare, and enterprise services where data needs to be secure, accurate, and trustworthy. The next one is Remote Procedure Call, or RPC, which is a protocol that allows a program to execute a procedure or function on a remote server as if it were a local call, abstracting the underlying network communication. The client sends a request with the procedure name and parameters, and the server executes it and then returns the results. It's widely used in microservices, distributed systems, and inter-process communication where low latency, function-oriented calls are needed. There are 2 basic types of RPC. Maybe we can call it as an example also, which are popular these days. The first one being JSON RPC, where A client calls the get balance with account ID on a remote banking server via the HTTP. The server processes it and returns the balance. The second example is gRPC, where a client may call, say, hello with a name on a remote server using protocol buffers over HTTP/2, and the service responds with a greeting. The next architecture is GraphQL. It is a query language for APIs and a runtime for executing those queries. It allows the clients to specify exactly what the data it needs, which reduces overfetching, that is getting more data than needed, and underfetching, that is requiring multiple requests to fetch all the data. In GraphQL, clients can request exactly the data they need, avoiding any unnecessary information. All queries are handled through a single endpoint, which simplifies communication between the client and the server. The GraphQL API uses a strongly typed schema that clearly defines the data structure and how different pieces of data relate to each other. For example, GitHub provides a powerful GraphQL API that lets developers fetch exactly the data they need about repositories, users, issues, pull requests, and so on. Next comes the WebSocket. WebSocket API allows the client and server to communicate with each other in real time. It establishes a two-way communication, allowing messages to be sent and responses to be received instantly without repeatedly polling the server for updates. Unlike HTTP APIs, which are request response, that is, client asks and server response, WebSockets keep the connection open. So both client and server can send messages anytime. For example, chat applications or stock trading platforms that display live prices, multiplayer games where every move counts, or apps that push live notification use WebSocket to keep information flowing in real time. Now let's talk about the different types of HTTP methods in REST APIs. I'm taking up this part because RESTful APIs are one of the most popular APIs architecture these days, and most of the APIs that you find over the internet are RESTful APIs only. So the RESTful APIs have multiple HTTP methods, each serving specific purpose in how clients interact with resources. They allow applications to perform various operations such as fetching, creating, updating, or deleting data. This structured approach ensures consistency and clarity in communication between client and server. So the first method, let's talk about the HTTP method, that is GET. The GET method is the most popular HTTP method used to fetch data from the specified server or resource. Its main purpose is to retrieve the data. GET APIs are considered safe as they do not create, update, or delete any data from the server. GET APIs are idempotent, meaning executing the same request multiple times will produce the same result. It will not change the state of the server. However, the response might change if the underlying resource changes. For example, fetching a customer details with a GET API after new customers are added will fetch more data. For example, prior to adding the new customers in the system, there were 5 customers already existing. Now, after adding a new customer in the system, the total goes to 6. So when you hit the GET API after addition of the new resource, you will get 6 records in the GET API response, whereas before addition there were only 5 records. Post. A post requests are used for creating new resource on the server. It usually sends some data to the server in its body. This data can be in different formats such as JSON, XML, or form data, and the content type header tells the server which format is being used. A post request is generally not idempotent because sending the same request multiple times might create duplicate data on the server. A put method is used to update an existing resource by replacing it completely with new data. When you use put on to update a resource, the request body should include the fully updated version of that resource. If some fields are left out, the server usually treats them as removed or resets them to default values. A put request is idempotent, which means sending the same request multiple times has the same effect as the sending it once. Even if you repeat the request, the resource will stay same in the same updated state. That means once you update the resource, it will keep on updating the same resource. It won't add new resource, but this depend upon the implementation, how the things are implemented. In case there is a validation message being added for duplicate update, in that case, you might receive a response saying that the records are already updated or there are no records found to update, kind of. But it all depends upon the implementation, how the put API has been implemented. Patch. Patch method is used to make partial updates to an existing resource. Unlike put, which replaces the whole resource, patch lets you update only specific fields without affecting the rest. Unlike put, which replaces the whole resource, patch lets you update only specific fields without affecting the rest. The behavior of patch makes it more flexible and efficient than the put method. In patch, usually you can update, for example, there are 7, 8 different fields in the API and you just want to update only 2 fields. Then in that case, patch request can be used where you can just send the only the 2 fields which needs to be updated in the request body, and that particular fields will only be updated. You need not send the whole 7 fields data like we do in put request. Delete. The delete method is used to remove a resource from the server. When a client sends a delete request to a specific URL, it permanently deletes that resource from the server. After deleting the resource, the server sends an HTTP response back to the client indicating the outcome of the deletion attempt. Options. The options method is used to determine the available communication options for a specific resource, such as which HTTP methods and headers are permitted. It plays an important role in CORS, CORS, which means cross-origin resource sharing, where browser sends an options request before making certain cross-origin requests like post, get, etc. to check if an action is permitted. Now, if we talk about the different status codes, ideally in GET request, you can expect 200 status code in the response with the data. For the post, generally 201 is the status code that is being sent in the response. With the maybe depends upon the implementation if the response in the post request comes with the data or not. The put request ideally sends a 201 or maybe 200. Patch also remains the same, like 200 maybe. And delete, ideally it should send 204, but sometimes the some of the APIs send 200 response code as well. In options is generally 200 only. Now let's talk about the API testing types, since the main core part of this video is regarding to show the different testing strategies and types and how to perform the API test. So there are various ways to test an API with each own purpose. There are most common approaches which I will be talking about in this video. The software teams can mix and adapt them in multiple ways to create testing strategy that best fits their needs. The first testing type we'll be talking about is unit testing. A unit test ideally checks a small specific part of the code in isolation without relying on other parts of the application. In APIs, a unit test can verify that the endpoint returns the correct response with the status code for the given request. It can also check whether an endpoint handles optional parameters correctly or returns the correct error code for an invalid request. For example, a unit test case for a GET API that returns a list of orders for a given order ID should verify that the correct data is returned in the response along with 200 status code. So ideally, maybe you can just check that the 4 different records are returned in the response with 200 status code. You need not maybe check the data integrity. Maybe you can write an integration test for checking the data integrity, or maybe more functional validations. Unit test is just basically to check if the API is returning that respective data in the respective format or not. Integration testing. Integration testing is performed to verify the various components of the software are compatible with each other. Integration test helps in verifying that the different API modules or different API modules or services communicate and transfer data efficiently as required between them. Let's take an example of an e-commerce application that has an order API and payment API. The order API creates an order while the payment API can process the payment for the order. The integration testing ensures that the order status is updated correctly after the payment. So when you make a payment using a payment API, the order API accordingly updates the order correctly. So the data is stored as a part of an integration. The data is correctly getting updated in the system. The integrity is being maintained. Consider another example of a travel application where the booking API creates a reservation for a user. The notification API is responsible for sending the confirmation. Integration testing ensures that once the booking is successful, the user receives the correct notification. Contract testing ensures that the consumer, such as the client application and the provider, such as an API, communicate according to the agreed contract. It verifies that the consumer sends requests in the expected format and the provider returns responses as defined. Contract testing verifies that both sides send and receive data in the correct format, helping to prevent integration problems caused by misaligned expectations. For example, the order service expects the payment service to accept payments and return specific fields in the response. While performing contract testing, the consumer test, that is the order service, verifies that when it sends these requests, it can correctly handle the expected response structure, whereas the provider test, that is the payment service, ensures its API return the field exactly as defined in the contract. The next testing type is JSON schema validation. A JSON schema acts like blueprint for a JSON data. It sets the rules, structure, and constraints the data must follow, removing guesswork and making it easier to understand and predict how the data will look and behave. JSON schema validation helps identify problems in the structure of JSON responses and makes it easier to trace and fix the root causes of API failures. JSON schema validation is widely used for validation related to API data, configuration, and data types. Functional test. Functional test. Functional testing is a key part of the software testing process. It ensures that APIs work as expected according to the business specifications. This type of testing typically checks fields validations, data accuracy, JSON structure, and response correctness. For example, in a login API, functional testing would verify that valid credential return a success response with a token, while invalid credentials return the correct error message. Security test. Authentication and authorization are two key concepts for any application to be secure. Security is important in API testing because APIs often expose sensitive business data and user information. Authentication ensures that the user or system accessing the API is genuine, while authorization defines what actions or data that user is allowed to access. For example, in an e-commerce API, a logged in customer that is authenticated can view their own orders, but only an admin who has an authorized access as an admin can access all the customer records. Performance test. Performance testing is equally important in API testing to ensure the application can handle real world traffic and workloads efficiently. It helps identify bottlenecks, response time delays, and scalability issues under different load conditions. By testing how APIs behave under stress, spikes, and concurrent requests, teams can proactively prevent system crashes or slowdown. For example, a payment API under heavy load ensures transactions remain reliable even during peak shopping seasons. End-to-end test. End-to-end tests verify the entire workflow of an application, considering all connected services. The basic idea behind end-to-end testing is to ensure everything works together as expected. In API testing, end-to-end tests validate real user scenarios rather than isolated endpoints. They help catch integration issues, problems related to data integrity, and gaps that unit or integration test might miss. For example, an end-to-end test for an e-commerce application could verify that a user can log in, add items to the cart, place an order, and receive a confirmation successfully. Now that we have explored testing techniques for APIs, let's look at some additional strategies to test them more efficiently. How to test the APIs? When it comes to API testing, a structured approach helps uncover issues early and ensures smooth communication between services. I have created this checklist that could prove helpful for you and your team while testing the APIs. And I have categorized it into different stages. The first one being the requirement phase, where understanding the requirement is equally important before we begin the testing part. So in this phase, we need to understand the API requirement and ask for clarification on what and how to test. We can also seek for clarity on request and response fields along with the data types to ensure accurate validation and avoid misunderstanding during the API testing. For post, put, and patch requests, always clarify the structure of the request body and its JSON schema to ensure your test align with the expected input format. In case of API integration testing, review the functional specification to understand the field mappings and how data flows between the APIs, ensuring smooth communication and accurate data handling across systems. It's helpful to request the Swagger link so that the API documentation can be easily accessed, reviewed, and understood. In the next stage, that is the verification and validation stage, verify that the get, post, put, patch, and delete APIs retrieve the correct responses as per the given request. In terms of GET request, verification should be done to check that the GET request retrieves the correct responses for the given request with query and path parameters. Verify that the data requested is correctly retrieved in the response. Verify for the negative scenarios such as sending blank data in mandatory fields, incomplete request body, invalid data, etc. in post, put, and patch APIs. Verification can also be done to check that the request body sent in post, put, and patch APIs correctly creates or updates the specified data in the system. Verify that the data type of fields and respective values like the date value, string, numbers, etc. in the response are correctly fetched or not. The data should also be as per the functional requirement specification document. Also verify that the JSON schema of the response should be as per the specification provided. Verification of the test cases related to different status codes such as 200, 201, 400, 401, 403, 404, 500, 503 should be performed correctly. Appropriate messages should be displayed for the respective status code. Inquire and check with the business team that if there is any redirection related status code that needs to be verified explicitly for any API. Validate that the response data and its format to ensure it matches the request correctly and contains the expected values. Validate the response schema to ensure that the API returns data in the expected structure and adheres to the defined JSON or XML format. Monitor API response time to ensure that the service is performing efficiently and meets the expected speed under various conditions. Ideally, the response should be retrieved within milliseconds. Pay attention to the response times that exceeds 2 or 3 seconds, as this may indicate performance bottlenecks that needs to be addressed. Verify that the APIs have correct authorization and authentication to ensure that only legitimate users can access them and that they have the proper permission for each action. Further diving into functional validation testing, verify the valid, invalid, and edge cases for the smooth functioning of the resources. Verify data integrity to ensure that the data sent and received through the API stays correct and consistent throughout the process. Perform a round of end-to-end testing to ensure that all the integrated APIs are working properly. An edge case would be to hit the GET API after creating a record using POST to verify that the data created appears in the GET request. Similarly, hitting the GET API and expecting the 404 status code after deleting the record to check that the data was deleted from the system successfully. Let's also let me shed some light on the tools that can be used for API testing. There are multiple tools that are available, but most of them that is widely used by the testing and the software teams are Swagger API or maybe Swagger UI, which provides a cool uh, outlook of the different APIs that are available for testing with their documentation, with the requests and the responses and every other details that is provided. So it serves as a documentation for the APIs as well. And it's a very good tool that can be used for primarily could be used for testing the APIs. Postman, everyone knows it's a very good tool that could be used for performing manual verification of the APIs. Insomnia is another tool that could be used for API testing. Bruno is another API client that can be used for API testing. It's an open source tool. Insomnia is also an open source tool. SOAP UI, this is especially for testing the XML requests by the SOAP APIs. The tool name is SOAP UI. Hopscotch is the same API client and can be used for performing API testing. Rest Assured, it's an automation framework in Java that could be used for performing API test automation. Supertest. Supertest is another framework, but this is a Node.js based library that could be used for testing the APIs using TypeScript or maybe JavaScript. XCS is another Node.js based library that could be used with TypeScript, JavaScript for API automation. Ideally, it is also used by many developers for performing the unit testing of the APIs. Playwright, everyone knows about it. It's a popular test automation tool. It has multiple, it supports multiple programming languages like Java, .NET, Python, TypeScript, JavaScript, and so on, and can be used for API testing as well. Though it is not we cannot use it as a deep dive for API testing, but it supports API testing. So you can go ahead and proceed and do the basic level checks for the APIs. Cypress, it's also a popular application that can be used, popular testing framework ideally, which can be used for performing writing API test automation. Okay, HTTP3, it's a Java-based automation framework that is must this is much faster than the REST assured. And ideally, I have seen many programmers or developers using this framework to write the unit test, integration test for their APIs. It works like a charm. You should try this. Okay, HTTP3 as well. Another library is request library. That is a Python-based library that could be used again for writing API automation test. Karate DSL. It's like a Cucumber framework, but ideally for API testing. Domain specific language. It's supposed like given when then kind of a uh, structure which can be like given when then steps can be written, and accordingly you can write the API automation test for the using the Karate DSL. Curl, everyone knows, like it's a popular tool again, maybe a command line based tool that could be used for performing API automation testing. Thank you so much for being with me in this video, and I hope you have learned uh, a lot from this video about API testing, writing the different API tests, performing the different strategies, using the different tools, and so on. In my experience, performing functional performance, security, and end-to-end testing provides a strong foundation for understanding the API's behavior. While conducting this test, you naturally gain deeper insights and identify additional scenarios that may require testing. Ask as many questions as necessary and continue testing until you are confident that the API is production ready. Happy testing. Thank you.